that even a rational function?
Well, because if you multiply by x, you'll get an x squared minus 5x plus 3.
Okay, so you're saying group it all together with the denominator?
Can we do that?
Yeah, let's do it.
We'll make it look better.
Because if I put this over 1, put that over 1, find a common denominator, that would mean I need to multiply each of these by x over x. Okay, so then in doing that, I get 3 over x plus x squared over x minus 5x over x. But then I'm going to reorder this and consolidate it down to a single fraction. So I get the x squared minus 5x plus 3 all divided by x. Which one?
The first part.
This one?
The 3.
I didn't multiply that one by anything. Because it already had the x in the denominator. I just multiplied the two of these to find that common denominator.
Okay.
Okay, so that becomes my combined function. So then what? How do I graph this?
Gotta find
Okay,
stuff.
are there factors of 3 that add up to -5?
No.
Unfortunately, no, there's not.
So you gotta put it in the quadratic.
Don't do it, Shane.
Okay,
Alright. Don't do it.
x-intercepts. Let's use the quadratic.
Oh, shoot. 5 minus
5 plus or minus square
25
root 25 minus 4
times 1 times
3 all divided by
2.
2. Okay, so that'd be 5 plus or minus the square root of 13,
Ugh, now it doesn't work out.
then all over 2. We can still get decimal values out of this stuff.
Disgusting.
Okay. Now, if we wanted to leave it in exact form, we can do that, but then we're probably going to want to find the decimal value to put it on the graph. Because I could write this as 5 plus the square root of 13 over 2 was 0, and 5 minus the square root of 13 over 2 is 0. Those are exact points, and that's correct. Okay? But if I need to figure out where to put it on the graph, that's where I'm going to have to actually figure out how big or small are those
You gotta
values.
put that in your calculator.
Yep, and we'll do that once we actually get at the graph, so we know where to put them.
Okay.
Okay, what else?
The bottom part is something to do with it.
Why?
Okay, while we're on intercepts, let's get the y-intercept. So how do we find y-intercept?
Set x equals.
Set x equal to 0. So I'd get 0 plus 0 plus 3 all over 0.
So
That's undefined.
there is nothing.
So that means we have none. Okay, no y-intercepts. Now why would that make sense in this case though? There's a vertical asymptote at 0. So vertical asymptote is that x equals 0, our denominator.
So you can't have asymptotes overlap each other.
I can't have an asymptote and an intercept overlap. That would be a case like that last one we did where we end up getting a hole, because they would cancel each other out.
Unless it's horizontal.
Yeah, so a vertical and an intercept. Yeah. Alright, what else?
And the horizontal or oblique.
Horizontal or oblique? How do we tell?
So x squared over x.
So x squared over x,
So it's oblique.
it'd be oblique.
Oh, gosh.
So x squared over x. Now let's think about why this one's easier than some of the other divisions.
X.
There's just an x.
So just think about what goes on.
I can divide these individually.
So
So,
x
When I get back to this,
minus 5.
Oh,
okay?
we just said that exactly.
Because that would just be x minus 5 plus the 3 over x if I went the whole way.
Oh,
It's exactly what I started with.
why? Oh,
So we don't want the 3 over x,
Okay.
right?
I wouldn't include this as part of the asymptote. It'd just be the y equals x minus 5. You are correct. We multiplied to pull it together. We divided to pull it apart. We just went backwards, which is why we ended back up
If
with
it's
that.
just all the way separated like that, then that just means you're going to be able to find out if it. Okay.
Okay, But we combined it to find some other stuff. So that was a necessary step.
I know, but like you could just look back at the first one.
At that point, yeah, this is the divided version, and then just ignore the remainder part. That becomes your asymptote. Okay, anything else we needed? We have x and y intercept, we have vertical, and we decided oblique asymptote in this case. Okay, that's all we found was x, y, and all types of asymptotes. So let's plot them. Okay, so x-intercepts. What are these values approximately?
Like 4-ish.
4.3? And what's the other one? .6, .7? Okay, so about 0.7. Okay, so then if I'm plotting those, 4.3 is going to be there. 0.7 is going to be about right there. Vertical asymptote we decided was at 0. So that's right on the y-axis. And then y equals x minus 5. How do I do that one?
It's just a linear, so.
Just like a normal graph, yeah. So y-intercept at -5. I'd cross here if I follow that 1/1 slope. So it's going to look something like that. So I have a vertical and I've got the oblique, and then we have the two intercepts there. So now what? Okay, how are those going to connect though? Chances are it's going to dip down underneath. Now, which one of these x values do you want to plug in to determine how far it dips?
Like 2.
Let's try the 2, okay, or 2.5, either one, I don't care. So let's choose one. I'm going to plug in the 2 just because it's a whole number. If I plug a 2 into this, what do we get?
Minus 10, -6 plus 3, so -3 over 2.
Okay, so -1.5. So then we're dropping down about right there. So that verifies that we drop underneath here. I like that. So now what? What's happening on the left side of that curve? This is definitely going to get closer to x equals 0 and go vertical. Or near vertical, I should say. The right side, we know it's going to approach the asymptote, but on which side? How do we tell?
We have to plug the number in on the side of it.
Okay, so what, back here, how did we determine the answer was no when it crossed, or that it didn't cross?
6.
We plugged the asymptote equal to the function. Well, what was the non-vertical asymptote here?
X minus 5.
X minus 5. If I set this equal to my function, then I can determine does it or doesn't cross.
Can you do it with the first one?
Yeah, it's the same function. Okay, so if I'm doing that, does it cross? No, that's a very good question. And in this case, I'd say that's actually easier. So x minus 5 equals 3 over x plus x minus 5. What happens?
X plus 5 cancel.
X minus 5, x minus 5, gone. I get 0 is equal to 3 over x.
So times x equals 0 equals 3, which
Okay.
we can't do.
So this doesn't work, so what does that mean?
It just approaches it, but doesn't cross.
It doesn't cross, it just gets closer to it. Okay, if you get an x equals a number, then it crosses at that value of x. Well, what do we expect to happen on this left side? Above or below? And why?
We don't have
We don't have
another x-intercept, so below.
another x-intercept, so I would expect below as well.
Oh.
So what are we going to plug in to see how low?
X equals -1.
Okay, -1, -2, -3, doesn't matter. Plug in something, and you could even plug in multiple to figure out where it goes. It depends on the instructions, how specific it asks. Okay, so if I plug in a -1, what do I get? So it'd be 1 plus 5 is 6.
Negative
So
9.
9.
9 over negative 1.
9.
So negative 9. Okay. What if I plug in a negative 2? Let's just see where that lands.
4 plus 10, 14 plus 3, 17 over negative 2.
17 over negative 2. Okay, so that'd be negative 8.5.
Yeah.
So they're about the same there. So then that was 5, 6, 7, 8, 9. So that puts us there. Negative 2, we are a little bit higher. About right there. So then it's going to look something like that. And then drop down next to the asymptote there. So it's probably a good idea to plug in 2 just so you have an idea of where that curve's going on that bottom side. That would be the graph of that rational function. Questions on the rationals?